Okay, so this is Data and Database Systems, and in today's lecture, my name is Iman Sarasigi, and I'm going to take this subject of yours. So this is our first lecture today, and basically we are going to see section number 1.1, describe different categories of data. Okay, so basically, what is meant by data? What is data? So as we know that data is raw, unprocessed facts, figures, or symbols, like numbers, text, images, sounds, and this is unprocessed, like it doesn't make any sense. It is raw. So what does it represent? It represents observations, like for example, weight, for example, and some measurements, for example, someone's height. That could be a data or details about things. Uh, like in a medical, for example, medical imagery, something like that. Then data becomes meaningful information because data is unprocessed and raw. It doesn't make any sense. So when it is processed, it becomes information. Okay, so information when organized, processed, and given context. Like for example, if I give you the number 23, it will not make any sense unless I give context to it. So for example, if I say someone's age is 23, or someone's height is 150 centimeter, something like this, so that then it becomes information. And then enabling reasoning, analysis, and decision making, like basically these are all the characteristics of data, and like how and why and where data is used. So by itself data may appear meaningless, like obviously if it's not given meaning it will become meaningless, but when organized, processed, and interpreted, it transforms into what information or valuable insights. Like I gave the example, someone's age and height, that support decision making, for example, in problem solving and innovation. And why data is used, where it's being used right now, like it's fueling everything from AI, artificial intelligence. We can see data analysis or data scientists, for example, careers. Like these are basically the careers that are related with AI and data analysis that deal with data itself. And business strategy, for example, and it exists in quantitative, like in numerical form, or qualitative, descriptive form. We will see it what later that means. So this is basically what is data, all of this thing that we deal with in our everyday life. Okay, so what are the basically the key characteristics of data? So first one is that it's raw and unprocessed. What does it mean? That data, it's not given any meaning, it's meaningless, and it's unprocessed. Like it's basically the basic building block of information, like individual census numbers, okay, or raw sensor readings before analysis. Then context dependent, its meaning changes based on how it's interpreted. For example, if I give the numerical number 50, or 38.5, for example, or 99.8, its meaning can change depending on what context I am using. For example, I might be telling you the temperature in Fahrenheit, or temperature in Celsius. Or for example, I might be telling you the weight, for example. Like it depends. So for example, a 10 could be age, a score, or a price. And then diverse formats, meanings that it can be numbers, it can be like here we saw that it can be numbers, quantities, information, graphs, like measurement, observations, facts, and everything. So it has very diverse formats, it has very diverse types, like images, videos, and text. Like when we zoom in the image, we see these little pixels, right? So those little pixels, these are also data. And all of the text that you basically see on the screen right now, or that you see in everyday life, that are also data. So for example, temperature readings, sales figures, ages, all of these basically are different examples of the data. Now, what is the difference between data and information? Like data is raw, unorganized, unprocessed. It has no meaning, meaningless, and it needs to be processed. So, data can be something simple and seemingly random and useless until it is organized. Okay. Then, information, when data is processed, organized, structured, or presented in a given context, like you give the meaning to some data, then it is made useful. It is called information. Now, next we're going to see some types of data one by one, and categories of data. So data can be categorized in different ways. First one, it's the quantitative data. We will see these structured and unstructured data in detail in the next lectures. But first we will see like what does quantitative data means, and what are its basically characteristics, etc. So quantitative data basically is information or data that can be measured. Like you can measure it in numbers, you can count it, like how we use numbers to count it. For example, the number of apples, the number of oranges, and expressed in numerical form. So it provides objective values that can be analyzed statistically. Like for example, if I were to make a bar chart or a graph chart, I can use the quantitative data to do that and to identify patterns, trends, and relationships. So, for example, sometimes in the news we see the pattern of like how many people, for example, voted in this party, for example. So this is also the quantitative data that is analyzed statistically, and it represents what numbers and measurable values, like you can measure them. So it can be divided into discrete data. Discrete data means the whole numbers, okay, and continuous data, that means values on a scale. So it is widely used in basically research, finance, engineering, and business analytics. So in examples, you can see age of people, for example, number of customers visiting a store, or temperature reading, sales revenue, all of these are examples of quantitative data. Then next is qualitative data. Qualitative data is descriptive. Like if we see the above quantitative data, like quantity, it's basically meaning it represents some quantity or numbers. For example, qualitative means like quality. You can think of it as this word. So qualitative data is what descriptive and non-numeric information. Like it is not related with numbers or anything. So it explains what qualities, characteristics or categories rather than quantities. And what does it do? It helps understand opinions, experiences, and meanings behind behaviors. And its focus is basically on qualities and attributes. And here you can see characteristics and categories rather than numbers. So it is often collected through surveys, interviews, or observations. So, for example, like for example, some student has made this Google form in which and they are a psychology student, for example, and they are basically conducting surveys, and they want to see, like, for example, whatever psychology project they are working on. So basically that survey is the example of qualitative data. Now that psychology student will use the number of responses he or she got and then convert it into statistics, and then see like how many people have responded correctly or not, for example. And it is useful for understanding opinions. Like for example, if I want to know your opinion on some particular thing, for example, that is happening in the world right now, or want to know your motivations and behaviors, for example, this is how qualitative data would be used. So for example, customer feedback, okay, satisfied, unsatisfied, or for example, like if in the Google form, it's written like your internet speeds, slow, moderate, or um, faster. So this is an example. Then product colors, interview transcripts, social media comments, all of these are different examples of qualitative data. The next is structured data. Structured data means it's information organized into a predefined format, that is rows and columns. Okay, so you have seen rows and columns in a database. Okay, so if we see here like how structured data looks like, so it's in a tabular basically format. Like this is how structured data looks like. Think of it like these rows and columns, right? So it's in a predefined format, rows and columns that make it easily searchable and manageable by traditional databases. For example, you are making a database using SQL language or MS Access, for example. So in those languages, the databases, if you're creating one, is the rows and columns, right? So you will put all of the data in rows and columns, and then you can easily organize them and manipulate them however you want. So that is example of structured data. So they are stored in relational databases. Relational databases means those databases which contain rows and columns, okay, or spreadsheets. So you might have worked with Excel spreadsheets or seen Excel, like, or Google Sheets, for example. So these are all examples of structured data, and they are easy to process with SQL. SQL is a structured query language, and the name suggests that it works with structured data. So SQL or structured query language and other tools, for example, all of this is used in structured data and best suited for tasks requiring accuracy and consistency. For example, a database administrator wants to create a relational database. So he or she will use the structured data, for example, use it in rows and columns, tabular format, and then process it. So for example, bank transactions, employee records, product inventories, all of these are examples of structured data. The next, unstructured data, is basically raw information. That means it does not follow a predefined structure or format, making it harder to organize. So obviously, if the data is like scattered or not predefined. It does not have any predefined structure or format or anything. It will be harder for you to organize it and analyze with conventional tools. So accounts for over 80% of data generated globally. That means that whatever like we are, for example, doing on the internet, searching for like on the Google search engine or anything like that, that all of that data is 80% um, con contains comes under unstructured data. So requires advanced tools like AI, artificial intelligence, NLP, means natural language processing, and computer vision. These all different tools basically to extract insights, and common in basically social media, multimedia, and IoT applications. So what are the examples of the unstructured data? Emails, okay, images, videos, voice recordings. Now, if we like think for a moment like how images or videos are in the examples of unstructured data, then not all of the images will be in let's say in HD format, right? Some of the images might be blurry or they might not have good pixels, but they are still images, right? So that is why they have included this example in unstructured data. And voice recordings, okay, and PDF documents, all of these are examples. Then last is semi-structured data. Now semi-structured data means how this semi-structured data and the unstructured data looks like. Okay, so semi-structured data is basically it combines both structured and unstructured. That means that it does not reside in traditional tables. Tables that is meaning basically rows and columns. So it does not reside in traditional rows and columns, but still contains tags or markers that provide a loose structure. That means it's basically a combination of what structured data looks like and what unstructured data looks like. So that's why if you see these images of semi-structured and unstructured data, they will both look similar, but they are not similar. That is because the semi-structured data is combined both the structured and unstructured. So it provides a balance between flexibility and structure, and why is easier to analyze than unstructured data, but less rigid than structured data, and often used in web applications, IoT devices, and log systems. So, for example, JSON files, XML documents, NoSQL databases like MongoDB, and sensor logs. All of these are different examples of where semi-structured data is used. Okay, next we are going to see some categories of data that contain, first of all, open data. Okay, open data means that any data that is available for anyone to use for free. So that means that anyone can access it on the internet and use it however they want. So it can be shared for any purpose, typically released by governments. So, for example, our government have, for example, released the number of people who live in the country. For example, the population of basically Pakistan, for example. So this is an example of open data. And then some organizations might uh, release their data, share their data, for example, WHO or World Bank or businesses in machine readable formats like CSV. CSV is the uh, Excel format basically. It's a file, and then JSON format also with open licenses that allow reuse. That being said, that open data has open license. That means that anyone can use it, reuse it basically, and then redistribute it however they want. And mixing with other data sets, you can mix it with other data sets if you want, fostering innovation, transparency, and social, economic, and environmental benefits. So that means that you can use it however you want. It's free to use for anyone. So first is characteristics, key characteristics we will see of each of these. So first one is public and accessible. That means that it's available as a whole, often via the internet at low or no cost. And then machine readable, that means it can be in two formats, either CSV or JSON format that computers can easily process and integrate. Okay, that means machine readable. And reusable and redistributed means that anyone can reuse it, modify it, combine it with other data sets, for example, and share it with anyone, even commercially under open license. And then universal participation, that means no discrimination against fields of endeavor, persons, or groups. That is no non-commercial restriction. That means that anyone can basically universally from any part of the world participate in open data, using it basically. So, for example, these are some of the examples like geospatial data. You can see maps, land use, and location information for navigation. For example, Google Maps. All of the data in the Google Maps can be used by anyone. Then census and statistics like population demographics, like how a country does the population demographics, the census, and releases the basically the demographics to everyone. Then economic indicators, like how our economy did in 2025, for example, or 2024, all of the statistics related to that, and social trends from national statistics offices, and then climate patterns also, air quality, and biodiversity information, then public health statistics, disease outbreaks, like how many diseases, what kind of diseases, were outbreaking in certain, decade, and genomic sequences. Like this, basically, open data is being used in every industry, like the education industry, and by use the governments, and in the health sector as well. The next is basically public data. So public data is information freely available for anyone to use, reuse, and redistribute. So you might think that basically this is the same as open data, but it has a difference which we will see in a while. Okay, so public data means it can be used by public and available for anyone, and it is typically from government sources like census, crime stats, laws, for example. So, for example, if you search on Google, Pakistan's laws, or the articles, for example, of the constitution, the official government website will pop right in front of you, and then you can see the whole PDF that will contain all of the articles of the constitution. So this can be example of public data, or it is sometimes from private entities, okay, serving transparency and innovation, but can vary in accessibility from open data sets to information requiring requests. Like sometimes some private entities might release some data publicly, but if one needs to access them, they need to request it. So that was, I'll say, requiring request. It includes statistics, records, and documents whose sensitive, personal, or national security data, for example, is usually excluded. Obviously, the sensitive, personal, or national security data will only be visible to people who are working in, that sector, not to the general public, and is usually excluded. And while it's accessible, it's not always in an easily usable open format. That means that even if you were trying to access it, you would not be successful because it's not in an open format. Next is the characteristics. Basically, first one is that it's accessibility, that is available to anyone. For example, the freedom of information request. Okay, then sources. That means what is the basically the source of public data? Where does it come from? Primarily government bodies like federal, state, local. Okay, but also research institutions. Sometimes they might release their data, non-profit organizations and private companies as well. And what is their purpose? Promotes government transparency. That means that if, like, for example, the government has decided to release the population demographics to its people, then the people have the right to basically uh, demand basically the government to be transparent. Okay, so, and accountability. Obviously, any data you put out there for the public to use, for anyone to access and reuse and modify it, you are basically accountable for it. Okay, so it should be like, it should not fall into the wrong hands or anything like that. And then innovation or AI ML training, there are like different examples of it, like Kaggle. If you might have heard the name of Kaggle, basically it's a website that has a lot of data sets, and the machine learning enthusiasts and all of these data scientists, well, they use these data sets, the whole data basically that is publicly available, for training their AI and ML models. Okay, so next is basically the difference between public data and open data. So public data is broad, and that means any data in the public domain, okay, available for use, while open data is a subset of public data. Okay, that means specific standards for being easily accessible and machine readable and reusable, often through APIs. Not all public data is truly open. That means that not all public data will always be available to, for freely used by everyone. So if we see the examples here, as I said, World Bank open data, global development indicators, for example, IMF data. Like IMF just released, for example, the exchange rates, the lending, the economic indicators, NASA Earth data, for example, Google Trends, search interest over time. For example, if like this Google Trends is basically a website, you can actually search it, and then you can see like what people are searching right now, what is most popular basically right now. Okay, then Kaggle, as I told you, that is basically a platform with diverse data sets for projects that people who are in the AI or ML field or data science science field, they can use it to train their models. And then Google public data sets, large data sets like GitHub activity, okay, historical weather, for example, and WHO Global Health Observatory. So these are all different examples, and many other examples also include. They are in the public data. Okay, next is basically the private data. Private data, obviously from the name, is private. It's not available to anyone. Okay, any information that can directly or indirectly identify an individual. That means, like, for example, your CNIC, that is private. Not everyone you will give your CNIC to, right? Your age or your, for example, your house number, your that is a private data. So it can that is basically any information that can identify an individual, such as names, addresses, financial details, your, for example, bank account number, anything like that, your medical records, those are also private data, and online identifiers. Okay, it is considered sensitive, requiring protection under data privacy principles and regulations like GDPR. GDPR is basically rules and regulations by the that is for the US, basically. These are basically laws that allow you to understand, like, how, if you were putting the data out there or information out there to the public, how you should behave, basically, like laws, basically. Okay, so it's distinct from public data because it's private and it focuses on an individual's ability to manage their personal information. So any personal information of yours is your private data. Okay, with laws and security measures like encryption, access controls, and everything implemented to prevent misuse, theft, and unauthorized access. Okay, next is the key characteristics. First one is data privacy. That means that the right of an individual to control how their personal information is collected, used, and shared. Obviously, not all of the individuals and not everyone will keep their data public. Keep their data private. Some people, they might be, like, for example, in the case of celebrities and actors, like when we search their name, their age comes up, their parents' names comes up, like their whole, like, history, biography kind of thing comes up. So that is an exceptional case. But in the case of, like, individuals like us, like you, we need to keep the data private. So private data, our personal information, anything, that is basically a fundamental human right. Okay, because personal things should be kept private. Then data protection, the security measures and processes like encryption, access controls, audits, all of these security measures used to safeguard private data from unauthorized access or breaches. And regulations, that means laws like GDPR. These laws are basically some laws are basically universal, like the GDPR, and some laws are specific to one country. Like, for example, if someone is living in Pakistan or any other country, that country would be imposing their own laws on that person. So laws like GDPR set guidelines for how organizations must handle personal data. Okay, imposing penalties for non-compliance. So if you see like the types of private data, first is the personally identifiable information. That means PII. That means your private personal information through which someone can recognize you, identify you. That is basically your name, your address, your email, your phone numbers, your social security number, or your CNIC, for example, or your passport number. Then financial information, for example, bank account numbers, credit debit card details, everything like that. And health information, or PHI, like medical records, genetic data, or anything physical, mental health details, for example. And then online identifiers like your IP addresses. Yes, the online identifiers like your cookie IDs, IP addresses, basically are the internet that you're using. It has its password, right? And not everyone will be able to access it unless you give it to them. So that is also online identifier. Then behavioral data, that means information about online activities and habits, that also comes under the. So these are all the examples that we have previously discussed, like criminal records, political opinions, religious beliefs. All of these are basically private data. Not every person would want to share their political opinions online, their religious beliefs, their philosophical beliefs. And if someone has a criminal record, sometimes in the case of when someone is applying for a job, for example, in the US specifically, so they ask for, like, if you have like, they ask, like, in the form, basically, or in the interview, whether you have committed a criminal a crime or not. So basically they check for, like, a criminal record. Okay, then next we have the internal data. So internal data is basically information generated collected and controlled within an organization from its own operations. So, for example, a company, let's take the example of Jazz. Okay, for example, so Jazz is a company that has their employees working, and it's a very big organization. Okay, they have their main head office in Islamabad. So all of that data that Jazz is dealing with is the internal data. No people or no person, no employee outside of the Jazz or this organization can collect the data and control it, right? So the internal data is comes from its own an organization's own operations systems, like whatever system they're using, and customer interactions such as sales records, for example, financial reports, website activity, and HR information. Okay, or all of the employees' data basically comes under internal data as well. It provides unique insights for internal decision making. So, for example, they want to make a decision on who will be the best employee of the month. Now, this information will only be for people who are the employees who are working inside the organization. And then performance analysis, whose performance is best, and in strategic planning, unlike external data from outside sources. So it's essentially the company's own proprietary information. Okay, that can also be like, think of it as the internal data, but companies own like private data which they do not want to like tell everyone about, allowing for a competitive advantage. Now, obviously, no company would ever want to put their sensitive personal data or internal data out there with their competitors, which would give them an advantage over it. Next is the key characteristics. So first one is proprietary, that is meaning controlled by the company, because internal data is within an organization or a company, so it's controlled by the company, often inaccessible to outsiders without permission. Unless the company gives you permission, then you can access it. And then primary, secondary, that means can be collected directly. Directly means primary or repurposed from existing records, secondary for new analysis. Then what are the sources? First is sales and finance, like transaction records, revenue, profit reports, budgets. Like a company has their own budget. For example, they make their yearly budget or monthly budget, like we are going to proceed with this. And then invoices, accounts payable, receivable, like for example, the account information of all the employees who received a salary, for example, who did not receive the salary. So these are they come in sales and finance. Then marketing, in marketing we see website KPIs, the key performance indicators, customer service, campaign performance data, and customer feedback. Like all of these are internal data. Okay, next is basically source. Next two sources are for HR and operations. So in HR we have the employee profile. Obviously every employee working in an organization has their own profile, right? Then their training records, who has completed the training, for example, who did not complete the training, performance reviews, best performance, worst performance, like this, and exit interview data. Okay, operations, in operations we have production data, and then defect reports, point of sale, POS data, app usage. So why is internal data important? It helps leaders understand performance and make data driven choices, and then reveals trends in sales, cost, and customer behavior. Obviously, with your internal data, you can first of all understand the performance, how, for example, your product, for example, if the company makes some products, how the product is performing, and then it can also reveal trend in sales, how many sales has this product done, what are going to be the cost if we upscale it. For example, unique data offers a distinct view of the business and market position. So you can see your market position as well, like in the market, where do you stand, where does your business stand, what are your competitors doing. For example, identifies areas needing enhancement. So from marketing to production, for example, some areas in your business need some enhancement, need some upgradation. For example, the marketing is not doing their job properly, or there is some loophole in that. So the internal data can help you in identifying all of this. So next, if we see the examples, we have the transactional data. That is the purchase orders, for example, sales history. Then we can see the demographics, for example, preferences, contact info of the customers, of your employees, for example, support tickets, feedback, all of that. Then digital activity, we have website clicks, how many people clicked on your website. That is only you can see, right? No other person is allowed to do that. And then app usage, for example, how many people are using your app if you made a mobile app, for example, like email open rates. For example, if you send a promotional email to like 50 people, how many of them open that email? And then ad clicks, how many people clicked on your ad, for example. And then in campaigns, previous test results, promotional code usage, employee profiles, like all of these are different examples of internal data. Research data. Okay, research data is basically, if we look at the name research, that means literally to research about something, to find evidence or facts, okay, to basically support our facts or observations. So research data is the evidence or proof, you can say, that includes the facts, observations, like for example, a scientist who is working in a lab might have research data about a plant he is researching on, then measurements, records, or other information. And it is collected, generated, or created to support, validate, and explain findings from a research project. For example, if you see movies, sometimes they with some scientists in that movie. So what are they doing? They're doing research, and their research is to basically collect the data. For example, they want to explain the findings or do some experiments also. So it exists in various forms, like digital files. Okay, it can be in the digital files, spreadsheets, images, code, for example, or physical items like lab notebooks, artifacts, for example. You can keep it physically or digitally, it's up to you. And it serves as a foundation for analysis. So it can be raw or processed. That means it can be raw, that means unprocessed in the data form, or processed like information like processed, meaningful form, and it's crucial for building upon existing knowledge, or making sharing and management vital in modern science. So usually it's like, if we see its examples in the next slide, it will be mostly used in the medical sector or health sector. But first we have to see the key characteristics. So first, its forms. Like it can be like, what are its forms? Basically, it can be numerical, like if someone is doing the survey or experiment, that is comes under numerical. Then visual form, for example, photos, in the form of photos, images, or videos. In it can be textual, like in transcripts and notes. It can be in audio form, for example, software, models, or physical objects like specimens and artifacts. Then types, what are its types? It can be primary or secondary. Primary means collected directly by the researchers, so whoever is doing the research, or secondary means derived from existing data. And what is its status? Can be raw, original, and unprocessed, as I already said, or processed and cleans, prepared for analysis. And what is its form? It basically includes both digital and non-digital formats. And we saw the physical, it can be in physical format or digital format. It depends. So if we see the examples, we have, like for example, numerical ratings, 1 to 5 scale or counts, blood pressure, for example, cholesterol levels. Like for example, doctors, for example, sometimes check the blood pressure and cholesterol level of the patient. So that is also a research data. They can use the previous findings of the blood pressure and cholesterol levels, or for example, the sugar of a person, the glucose fasting of a person, to analyze like what is wrong with this patient, this person. Sensor readings, chromatograms is used in chemistry. A gene sequence, and number of red versus white cars sold. For example, if someone is working in the sales industry and selling cars, then in documents it can be text, emails, reports, case study findings, as in the case of lawyers, for example, they might, so I was saying that in the case of study findings, it can be like, for example, lawyers have these case study findings of previous cases. They don't like throw it and waste it. They basically use those case study findings to connect the points. So it can be used, that is basically the also the example of research data. And then all of these analysis code algorithms, images, video, climate model, and economic figures, all of these are examples of research data. Like these, they are used in every industry. Then next we have the last exam category, basically is the big data. So now big data, basically all of the data that is not able to, you can say, process completely. Basically, it's massive and complex data sets. Okay, that are too large for traditional software to manage. So you cannot keep them in Excel files or the spreadsheets. Okay, so they are characterized by the five V's. And what are those five V's? First one is volume. That means huge amounts. Like what is basically, if we see here, the size of the data volume. Then velocity. That means the speed data appears and disappears. Veracity, that means the reliability of the data. And value means the relevance. And variety means like how many types of data. Like obviously there are different types of data. So what is the types and the variety? So organizations use big data gathered from sources like social media, sensors, and transactions to reveal patterns, trends, and associations. For example, you can see here the example of Netflix recommendations. So obviously, the Netflix recommendations is like an example of big data in a sense that Netflix has their own database and everything, and they use it to. Then we only have three slides left. First is basically the five V's are it's the key characteristics of big data. Right. First one is the volume, basically the amount of data. The volume of data, basically terabytes, like in petabytes, zettabytes. These are basically the units in which data can be measured. So, for example, megabytes, gigabytes, like this. Then velocity, that means the speed at which data is generated and needs processing, like real-time streams. And then variety means diverse formats, like we see in the last slide here, like what kind of a variety basically data can have, including text, images. Like there can be so much data, but its format is different, like files, videos, images, sensor data, structured databases, for example, unstructured data, for example. Then veracity, that means the accuracy and reliability of the data. So, like how much of the data is accurate and can we rely on it or not? And then value, that means the potential to derive meaningful insights and business benefits from the data. Okay, then next is basically sources of big data, like how it's generated. What is its source? First of all, is the social media, for example, all of the posts, likes, shares, and videos, reels, for example, that is the source of big data. Then machine or sensor data, the IoT devices, traffic cameras, the smart cams, for example, weather satellites, for example, which contain the data in itself. These are the source of big data. Then transactional data, for example, the customer purchases, financial records, all of it, and human generated, for example, emails, photos, web searches, all of that is sources of big data. So why big data matters? Like it feeds algorithms. Like in the case of AI and machine learning, it feeds algorithms for training models like ChatGPT, right? So if the big data, for example, as I gave the example of Kaggle in the previous slides, so Kaggle datasets basically are used by AI and ML people who work in this field basically. So they use it to train their models, like their existing model or a new model, for example, like ChatGPT, for example. And then it helps companies understand customers and optimize operations and powers personalized recommendations, like in the case of Netflix, for example. Then aids in disaster management, healthcare, and education, like all of these sectors, this is where is being used, and other sectors as well. Okay, so next is basically the all of the examples. So first of all, the personalized recommendations, like the Amazon, for example, if you go on Amazon page, it will give you personalized recommendations on what is the most bought product this month, for example, Netflix, or for example, your YouTube search history, for example. Then targeted advertising, that means companies use browsing data to create highly specific ad campaigns. So for example, companies might create their own ads and put it on all of the social media platforms in a specific on a specific time, like for example by an ads expert, so to target basically for example teens or adults or young people. Then route optimization, that means UPS uses sensor data, traffic, and weather to find fuel efficient routes, like avoiding left turns. So in the case of, like for example, routes finding or ways finding, to optimize them, big data is used. Then traffic management, where it's being used in traffic management, like Google Maps. Yes, Google Maps uses real-time data. This is also an example of where we saw, I think, research data, I think, or any the other data example, for example. Yes, Google Maps uses real-time data to predict congestion and find fastest route. So, for example, you have like put in the search bar, like I want to go to this destination. So the Google Maps will suggest you that shortest route, and it will also tell you if there is any traffic that will be colored in red. So this is how the big data is working. And then in drug discovery, like in the health sector or medical sector, pharmaceutical companies use big data to speed up research. So these are all of the basically that we see the types of data, categories of data, and examples and their key characteristics. So